last week, so my Thursday people will actually help. So I'll help them a lot. All right, so cardiac muscle tissue, they have some specific characteristics that are related to cardiac muscle tissue only, not skeletal muscle tissue. They have automaticity, so they self-depolarize, or they produce action potentials on their own, and it's actually really cool. You can take cardiac cells in a petri dish, and you can look at them under the microscope, and you'll see one contracting and depolarizing at one pace, and one depolarizing at another pace. And so when you stick them together, whichever one is depolarizing the fastest will take the lead as the pacemaker. In your heart cells, we have two different types of cells. The first one is the pacemaker cells. These guys actually produce their own action potentials. So they hit threshold, and then they produce an action potential, and then they hit threshold, produce an action potential, hit threshold, produce an action potential. And the way that they do that is very rhythmic. And then they send that electrical signal onto the contractile cells, and those guys contract. So it's autorhythmic, and it's without neural stimulation. You can pull a heart out of the chest, and it will continue beating until it runs out of ATP and oxygen, until those cells die. Okay. They also have extended contraction time. So when we looked at skeletal muscle contraction, it lasted maybe 100 milliseconds. For cardiac muscle, it's 800 milliseconds. So it's much longer. So these guys are going to contract and relax, and this takes a long amount of time to do that. They also have long absolute refractory periods. What is an absolute refractory period, guys?
Depolarization.
Where you can't stimulate it again to produce what?
Another action.
So you can't stimulate it and produce another action potential. And this is important. They have to have a long absolute refractory period because you don't want those cardiac muscles going into summation and tetany. You don't want them to contract maximally, all right? You want them to contract and relax. And why would you not want summation or tetany in heart cells? What is the goal of the heart?
To pump the blood.
To pump blood. And if it's in tetany, if it's maximally contracting, are you getting the blood in and getting the heart filled with blood and then getting it contracted and pumped in an orderly fashion?